Welcome back. Today I'm going to be going over this system of equations question that usually comes up on the SAT. Um, Once again, thanks to Anico the AI for providing this specific question in their free resources tab. But before I get started, please give this problem a try yourself. Okay, let's get started now. So here we have one of the two equations in a system of linear equations is given. The system has no solution. Which of these four answer choices could be the second equation in the system? So right away, right, a key things to like jot down is that the system has no solution, right? So what that tells us is that there's going to be no intersection, right, between these two equations here. And because we're trying to look for the second equation, right, and we're given the first one, I think it's always a good idea just to make this more readable, right? So what I mean by that is just remove all these fractions, right? So to do that, well, you can actually multiply everything here by 350, and the reason is because that's going to get the 5 out, the 7 out, and the 35 out, right? Once you do that, right, because I don't want to waste any of your time, of course, you actually get this, right? If you simplify everything and put the x and y's in one side, you get this equation, right? So this becomes this. 49x minus 60y equals 16. Now, if a system has no solution, right? And again, that's actually very important. If a system has no solution, what that means is that, let's say you have an XY graph here, right? You have a line that goes like this. And for it to have no solution with another equation, that means another line has to be exactly parallel, right? So if these two lines are parallel, what that means is two things. First, the slope have to be the same, right? The slope of this line, because it's increasing by the same value, has to be the same as the slope of this line, right? And likewise, actually, the y-intercepts, right, have to be different, right? Because if the y-intercepts were the same, well, these lines would just be the exact same, right? So the y-intercepts have to be different for these types of equations, right? If you want no solution. So with that in mind, right, we're trying to look for essentially an equation here where the x and y coefficients match, but the constant term is different, right? Because if you think about it, right, in a linear equation, that constant term is kind of what determines the y-intercept, right? So here, right, we're looking for a different constant term, right? But we want the coefficients here to be the same for x and y. So what you can do is compare each answer choice, right, to this equation and see which one gives you the same x and y coefficient but a different constant. So this first a, like this a here, right, you're dividing by 6, 49 divided by 6, so let's divide everything here by 6. So 49 over 6x minus 10y equals 8 over 3, right? If you divide all of this by 6, when you do that, you realize that you get the same equation. So it can't be A, right? Because this would actually make the system have infinite solutions, right? It's the same exact equation. Let's look at B. In B, you're dividing by 60, right? So let's divide the entire equation by 60, the original. So that's going to become 49 over 60x minus y equals 16 divided by 60, right? 4 over 15. And because this is y equals, right, let's make it like that. So if you want to make it y equals, well, you add the y here, right? So that cancels out, and you subtract the 4 over 15. So you get 49 over 60x minus 4 over 15 equals y. You'll realize, well, again, that's the same exact equation. So it's not b either. If you look at these remaining is going to clear something up. But if you look at answer choice C, you have a 98x. So let's multiply this entire thing by 2. So you get 98x minus 120y equals 32, right? You'll realize, well, it actually, the y coefficients here, right, don't match. So it actually can't be C either. Because remember, right, the y and x coefficients have to match. You just want the constant term to be different. So it's not C. Of course, that does leave D with our answer choice, but just to check, right, you have a uh, negative 98x, right, and this is set equal to negative 35. If you think about it, right, let's multiply everything by a negative. So if you multiply this by negative, right, you get negative 98x plus 120y equals negative 32. So now, right, look at this. The negative 98x is match, the 120y is match, but the constant term is different, right? So that's how you know these are answer choice here. So yeah, whenever you have two systems, you have a system and there's two equations, if they have no solution, try to look for the same x and y coefficients, but a different constant term. So that's actually the first way to do this problem, right? Another way to do this problem is to type it into Desmos, right? So you have 4 over 5. Let's type the original one first. And when you do that, right, you get a line, of course. And essentially what you're going to do next is take each of these answer choices, right? And right, type them in and see which one don't give you any solution, right? In this case, to save some time, I'm just going to put answer choice D so you can see how that looks. But if you type that in, right, you'll see pretty quickly, well, look, these lines are parallel to each other, right? They don't intersect at all, right? So that's again a good sign that it's going to be the answer choice, right? Because the lines are parallel, they don't intersect at all. So hopefully that made sense, right? You could use the Desmos method, in my opinion, it is much easier. But I showed you the first method because you also have to know the mathematical way of solving it, right? You shouldn't rely on Desmos too much, but regardless, right? I hope you understood everything, and if you have any questions, leave it down in the comments. Please hit that subscribe and that like. And of course, we post daily videos for ACT and SAT prep. So if you want to be notified when they come out, please hit that notification bell. But thanks for watching, and I'll see you next time.